Okay, now, we could also represent the graph of this function by shifting this graph 0.6 units to the left. So let me just slop down another graph of what I hope is something resembling the logarithmic. Well, I blame the board on that little glitch there. Okay, so I'm going to say maybe the graph looks something like this. So here's 1, here's 2, here's 3, I guess 4 would be out about here. So let's extend the graph out to there. And then I'm going to say, okay, well, this should be 2. This should be 1. See, now my 1's up too high relative to my 2, so I got too flat on the curve here. Okay? Now I'm going to pretend that that's evenly spaced. Okay? Remember, I just did this freehand. I didn't plot points, right? And then 1/2 should be at -1, right? That looks okay. And 1/4 should be down here at -2. That looks okay, but yeah, my 2 isn't great here. 2 should be
Sorry.
or 1 should be a little lower. Okay? So I don't have a particularly good graph. I don't expect to get a particularly wonderful solution. But this is y equals log 2 of x. Okay? To get the graph of log 2 of x plus 0.6, I have to shift 0.6 units to the left. So I do that. First of all, let's see, -1 then would be like here. So my, well, that's not it. So 0.6 would be about here. Okay? That's where my asymptote would be, because I've got the vertical asymptote at x equals 0 for this function. When I shift to the left, the asymptote's going to shift over to -0.6, so the graph is going to come up kind of like this. Okay? Now let's be careful and shift everything. Okay, so the x-axis basically, I'm sorry, the y-axis shifts over -0.6 units. This point will shift over -0.6 units. This point will shift over -0.6 units. And this point over here will shift over -0.6 units. Okay? So all these green arrows are -0.6. I didn't, well, I could do it. -0.6 here, -0.6 here. So my graph points are going to be here, here, and here. And the, the x equals 1/2 point will shift over to here. And the x equals -1/4 point will shift all the way over to here. And my graph will be asymptotic to this line, so that my graph is going to probably look something very much like this. Okay? So now I have a graph of y equals log base 2 of x plus 0.6. Now if I want to rewrite my f of x function, there it is, right? So now if I want to get f of 0.6 equals what? Well, 0.6 is going to be about here.
Left 0.5.
Little past x equals 0.5, not sure I wrote it very well. So I shift over here. Well, now I'm going to say f of 0.6 is about 0.4, according to this graph, which isn't done very well, okay? Well, that's pretty consistent with my 0.3 that I got here, right? The graph is a little different. I don't draw it the same every time. So I get this result, which is consistent with this. It's not exactly the same, but it's close enough that I can accept that f of 0.6 and log base 2 of 1.2 should give me the same thing. Okay? So I'm going to say that these are reasonably consistent. Okay? That this value and this value aren't exactly the same, but they're not that much different. I think this one's way too high. That one's closer than this one, but it's okay. Okay, then if I want f of 1.6, what's my estimate according to the green graph? Well, here's x equals 1.6. Let me find a different color. Hopefully one that has enough chalk to write with. So here's 1.6, right? And I use the graph of, the green graph, and I see that f of 1.6 is approximately what? It's between 1 and 2. It looks like pretty much 1.3. And there it is. The AR didn't quite go to the right point. And what did I get down here? I got 1.35, right? Now, that's not too bad, okay? That's pretty close. So I'm going to say that this and this are pretty close. Okay? Now I think it would be well to think through what this example shows us about shifting functions and about why you've got to shift the function to the left. Okay? Think about it.